Investors can use a diversification strategy to reduce portfolio risk. We can minimize the exposure to individual risk by increasing the numbers of independent stocks in our portfolio. But we cannot remove all risks by simply investing in a large number of stocks. Systematic risk still remains even after extensive diversification. On the other hand, unique or firm-specific risk can be eliminated by diversification. In the graph, x-axis is the number of securities in a risky portfolio. Y-axis is portfolio standard deviation. We can see the marginal reduction in risk from diversification becomes smaller as n increases. The total risk approaches the level of non-diversifiable risk. First, let's take a look at a simple diversification strategy. Just invest equal weight in n securities. The portfolio variance can be simplified to the following equation. Average variance divided by n plus n minus 1 divided by n times average covariance. For now, let's not worry about how to derive this equation. We'll come back to it when we get to the second video lesson. As n is approaching infinity, the first term becomes 0. For the second term, n minus 1 over n becomes 1. The average covariance remains and is the non-diversifiable risk. Investors are interested in efficient diversification, creating a risky portfolio to have the lowest possible standard deviation for any given level of return. We want to find the mix of weights in securities to minimize the standard deviation of the risky portfolio. For now, we'll focus on creating a risky portfolio from only 2 risky assets. Suppose we have an equity fund denoted by E and a debt fund denoted by D. The portion invested in the debt fund is W subscript D and W subscript E for the stock fund. The expected return, standard deviation, and covariance are listed in the table. On the exam, most of the time, correlation is given and you need to calculate the covariance. Correlation times standard deviation of D times standard deviation of E. When we combine these two assets in a risky portfolio, the portfolio expected return is the weighted return of the bond and equity fund. The portfolio variance is the weight squared times variance plus 2 times the weights times covariance. In the example from the textbook, the weight for the debt fund is 40%, 60% for the equity fund. The portfolio expected return is 0.4 times 0.08 expected return of the debt fund plus 0.6 times 0.13 expected return of the equity fund equal to 11%. Plugging the numbers into the variance formula, the portfolio variance is 2%. Taking the square root, the standard deviation is 14.2%. Now let's take a look at how correlation impacts the diversification benefit. The diversification benefit is greater when correlation between assets are smaller. Correlation is always between -1 and 1. There are 2 special cases. First, perfect positive correlation. When correlation is 1, the 2 assets move in the same direction. The second case is perfect negative correlation, with correlation being -1. When one asset falls, the other one increases. For perfect positive correlation, the portfolio standard deviation is simplified to the weighted average of the component standard deviation. There is no diversification benefit at all. For the second case, perfectly negative correlation, if the weight in the debt fund is equal to equity fund standard deviation over the standard deviation sum, we can get a portfolio variance equal to 0. Essentially, we can eliminate all the risk. The graph shows how correlation impacts the diversification benefits for the risky portfolio. The x-axis is the weight on equity fund. The y-axis is the portfolio standard deviation. In the example we just looked at, sigma of the debt fund is 12% and the sigma of the equity fund is 20%. At 0, when nothing is invested in the equity fund, 100% is invested in the debt fund. The portfolio standard deviation is just equal to the standard deviation of the debt fund at 12%. At 1, when 100% is invested in the equity fund, the portfolio standard deviation is the equity fund standard deviation, 20%. For perfectly positive correlation, the portfolio standard deviation is the weighted average of the component standard deviation. That's just a linear relationship and is shown by the yellow line. For perfectly negative correlation, the portfolio standard deviation also has a linear relationship, but at a specific weight, the portfolio variance can be 0. It's shown by the dashed blue line. For correlation closer to -1, the curve will be closer to the V-shaped line, as you can see in the dashed blue line that has correlation of 0. If we have a correlation equal to -0.08, we will have a steep curve really close to the V-shaped line like this. For correlation closer to 1, the curve is flattened and closer to the straight line, as we can see in the purple line with correlation equal to 0.3. For correlation equal to 0.8, the curve is even more flattened like this. Just keep in mind, all the curves go through the same y-intercept and the point rank S is 1. For efficient diversification, we want to minimize the portfolio variance. In the minimum variance portfolio, it has the lowest standard deviation that can be constructed from risky assets with a given correlation. The formula for the weight on the debt fund in the minimum variance portfolio is variance of equity fund minus covariance divided by the sum of debt and equity fund variance minus 2 times the covariance. The way I memorize this formula is numerator being variance of the other risky asset minus 1 times covariance. 1 is the number of variance terms before the covariance. There is only one variance term in the numerator. Denominator is the sum of the two variances minus 2 times covariance. 2 is the number of variance terms in the denominator. A side note, we can relate this formula to the weight for the debt fund in the perfect negative correlation case. Is equal to equity fund standard deviation divided by the sum of the standard deviation. Is similar to the first part of this formula, but with standard deviation. The minimum variance portfolio is one of the portfolios on the portfolio opportunity set. It shows all combinations of portfolio expected return and standard deviation that can be constructed from risky assets. In the graph, we have the opportunity set between debt and equity fund at various correlation level. To construct this graph, first identify the debt fund and equity fund on the graph. Second, graph the line for perfect positive correlation with correlation equal to 1. It's just a linear line between the 2 points. That's the yellow line. Third, graph the line for perfectly negative correlation with correlation equal to -1. It also has a linear relationship, and the portfolio variance can be 0. That's the y-intercept. Draw a line from y-intercept to E and another line to D. That's the orange line. For correlation closer to -1, the shape of the curve looks more like the orange line. For example, for correlation equal to 0, the opportunity set is represented by the blue line. It looks like the squeezed version of the orange line. For correlation equal to -0.9, the curve would be like this. On the other hand, for correlation closer to 1, the curve is flattened and closer to the yellow line. The gray line is for correlation equal to 0.3. For correlation equal to 0.9, it would be more flattened like this.